Okay, well, we have found the standard error. We've worked with confidence interval. Now the next thing to do is work with a hypothesis test. So a recent study asked college students to indicate the level of alcohol use. And in this example, we compare the group of students who said they are light drinkers to a group of students who said they were heavy drinkers. Each student was also given several cognitive skills tests and assigned a cognition Z-score based on the performance on these tests. The 83 students who said they were light drinkers had a mean cognition Z-score of 0.1302 with a standard deviation of 0.75. And that was 83 students. While the 16 students who said they were heavy drinkers had a mean cognition Z-score of negative 0.2338 with a standard deviation of 0.65. Test using a 5% significance level to see if there's evidence that heavy drinkers have a lower mean cognitive level than light drinkers. So test to see if there's evidence that heavy drinkers have a lower mean cognitive level than light drinkers. If the results are significant, can we conclude from this study that heavy drinking affects cognitive ability? Well, let's get started. Our first thing is to check the conditions. Well, 83 is greater than or equal to 30. So that's okay. 16 is less than 30. But we're going to assume normality since we do not have the scores for each person, so that we could then do a dot plot and see if it's symmetrical with no outliers. So our null hypothesis is that the mean of light drinkers equals the mean of heavy drinkers. Our alternative is that the mean of light drinkers is greater than the mean of heavy drinkers. Now, you could have these reversed, and if so, you would have that the mean of heavy drinkers is less than the mean of light drinkers. So our definition, mu sub L is the mean cognition Z-score for college students who say they are light drinkers. And mu sub H is the mean cognition Z-score for college students who say they are heavy drinkers. So we've checked our conditions, set up our hypotheses, and identified or defined our parameters. So now we have to come up with the test statistic. Because it's mean, it's a t, and it's in general the statistic minus the null over the standard error. Specifically, it's x bar sub L minus x bar sub H minus 0 over the square root of S sub L squared over N sub L plus S sub H squared over N sub H. With numbers, that would be 0.1302 minus a negative 0.2338. All over the square root of 0.75 squared over 83 plus 0.65 squared over 16. That's getting the numbers from the problem. So if we look at this, we have 0.1302 minus a negative 0.2338. That gives us 0.364. Now the denominator, we have 0.75 squared divided by 83 plus 0.65 squared divided by 16. And then we need to take the square root of that number, which is 0.182. So we have 0.364 divided by 0.182, which is 2.00. If you did it with heavy minus the light, you would have a negative 2.00 here. Now for the p-value, the way I have the alternative written, it's a right tail test. If you reversed it, it would be left tail. So it's T CDF as a right tail test. 2.00 becomes our lower limit. 999 our upper limit. 15 is our degrees of freedom, because the smaller sample size is 16, and if we take 1 from that, we get the 15. So we have TCDF, 2 is our lower limit, 999 is our upper limit, and 15. And we get 0.0320. Now, in this case, you were given a significance level of 5%. So since p-value is less than significance level, or is less than a 5% significance level, we reject H sub 0 and conclude that there is evidence that students who say they are heavy drinkers have a lower mean cognitive level than college students who say they are light drinkers. Now, there is the additional question that says if the results are significant, can we conclude from this study that heavy drinking affects cognitive ability? And we can't. We cannot conclude that heavy drinking affects cognitive ability since the data came from an observational study, not an experiment. There are many possible confounding variables, the least of which is the fact that this was self-reported.